All right, today we're doing a little compound interest and some loan payments. This is the basic formula for compound interest, but let's kind of discover what happens with it. So, happy birthday. Here's $3,000 to save. It's one of those birthday presents that you don't actually get to use right now. So whoever gave it to you is making you put it away in a bank or things like that. So there's 3 different banks that approach you for keeping money with them. Alpha Bank, 6% interest compounded. How often, guys? Annually. That means one time a year. Like annually, it's just once a year. The second bank, Beta Bank, offers you 6% interest compounded quarterly. What do you think quarterly means? How many times a year? 4 times a year. And the third bank, Gamma Bank, offers you 6% interest compounded monthly. So that would be 12 times a year, right? You get it every month. Well, we're going to fill out the chart to kind of visualize what happens. I know we've done this back in Algebra 1 a little bit, but it's nice to kind of see it happen. So I think we already know without doing the math which probably is the best option, but let's just see why it's the best option. So Alpha Bank, how much money did we start with? $3,000. So in 0 months have passed. This is like initially we put $3,000 into the bank in that case. Then how often are we earning interest for Alpha Bank? That was once a year. So basically, on month 1, how much money is still there after 1 month has passed? $3,000. We haven't earned any interest yet. 2 months have passed. How much money is still in the bank? $3,000. We won't get interest until right down here after 12 months have passed. So would you be cool with the fact that we can fill $3,000 out all the way down, like we sat there in January, February, March, all the way down till finally it's December time and we get some interest on this thing. So how much interest? 6%. We will take our calculator and we will take our starting value of 3,000 and we will take it times 1.06 because it's exponential growth. Right, we'll add the 1 to it in that case, and it was 6%. So punch her in, and I got $3,180. So we make that money sit there, and it took a year to get some interest, but finally we made $180 just by putting the money in the bank in that case. Cool? So what about if we would have went to Beta Bank? How much money do we start with again? $3,000, but we get our interest compounded quarterly. So we'll get it 4 different times in a year. So if we take the 12 months and divide it by 4 real quick, like how many months will it take until we get our first interest? It'll take 3 months, right? We're getting interest 4 times a year, but it takes 3 months. So in the first month, we got nothing. In the second month, we got nothing. But all right, it's now time for that 3rd month in that case. We're going to get, here's the trick. Here's where the average person in the real world doesn't quite understand. We are not going to get 6% interest that first quarter, right? We get 6% interest throughout the whole year's time. So since they're giving us the money quarterly, let's take 6%, grab your calculator. Let's take 6%, and you have to divide it up by how many times you're getting interest that year. How many times are we getting interest that year? 4 times. So this quarter, we only get this 0.015 interest, right? But then we'll get that again and again and again, right? It sounds like we're not going to get much money out of that, but by the time the years pass, it should be more than before. So we'll see why. So let's take our $3,000 times 1.015. And did you get $3,045? So, good. That's going to happen for another 3 months. Because in the 3rd month, nothing happened. Or excuse me, in the first 3 months, nothing happened. Then we got $3,045. And you could look already, we're already ahead. It's like if you wanted to go to the bank and say in April or whatever, it's like, whoa, we got 45 extra bucks there than what we had before because that other money was just sitting there doing nothing. So now here's the real trick of why compound interest works is because what are we going to take interest on now? $3,045 is sitting there, not the $3,000 from before. We have more money to take more interest in. So now we'll take our $3,045 times the 1.015, because that's going to earn that 6% interest quarterly, you know, in that case. And would you believe that came up with 3,090, and we'll call that 67 cents. Is that okay? Instead of 68 cents. So the bank's not going to round it up. I called it 68. The truth is, I don't care if you call it 67 cents or 68 cents, in my opinion. I'm not going to mark you wrong either which way. But that's going to happen for 3 months because it's sitting there, right? Then this 3,090.68 is going to earn interest, right, another time. So we'll take that number, that 3,090.68 times our 1.015, 3,090.68 times 1.015. And we get $3,137.04. And so far we've earned interest 3 times, right? Here was our original amount right here. Here was our first time, our second time, and our third time. Don't we have one more time where we're going to earn interest? So you can punch that in. I don't need to do it for you, but take it times that 1.015 again. 3137.04 times 1.015. And would you believe that's 31.84 and 10 cents in that case? 31.84 and 10 cents. How come we got more money from Beta Bank? It ain't much more money. In the long run, it's an extra $4.10, right, for this 1 year. Because here, by the end of the year, we got 31.80. Here we got 31.84 and 10 cents. But why did we get more money this in Beta Bank than we did in Alpha Bank? Good. We learned that it was because we got interest on top of interest on top of interest on top of interest, so we earned money on top of more money that we got. That's why that happened. So what do you think about Gamma Bank? How many times are we earning interest this time? 12 times. Should it be more than Beta Bank in that case? Yeah, the more times you can get interest, the better. But the tough part is, let's start with our 3,000. And we have to take the same 6% and realize what we're actually getting per month. So we'll take the 6% and divide it how many ways? 12 ways. So let's divide it 12 ways. And every month we're going to get a 0.5% interest in that case. You know, it's like 0.005. And a half times 12 is 6 in that case. So it'll add up to 6% as we go. So I'll do the first one for you. 3,000 times 1.005. And I got 3,015 bucks. You can go ahead and take the new result times 1.015. You're going to have to do that every time. So take 3,015 now times 1.005 and fill that out for the rest of the way. We'll round, just use math rules to round. If it's 5 or bigger, round up. If it's not, round down, whatever, you know. So I'll pause the video for you. You can go ahead and fill that out and check your answers with mine when you're done. So after you punch it in, round into 2 decimal places because it's money, I came up with $3,185.03, which surprisingly to me isn't much more than quarterly. It's not even $1 more, you know. It's like, oh, you would think that you would get a lot more money because you get interest 12 times a year, but it's not much. But the simple fact is because it only happened for 1 year, right? What if we stretch this out and let time do the work for us? And that's the real trick to making money if you want to invest, is you got to let time take its course. So we'll go back and pretend that this birthday present was actually your true birthday, like the day you were born, and somebody, usually a grandparent or something like that, puts amount of money, in this case 3,000 bucks away, and they're going to let you wait until you're ready for college for that. So that would be 18 years later. Cool. So roughly, you know, sometimes it's sooner, depending on when you are born and all that. But let's do this. Alpha Bank, and we're going to use this formula right here, where A is the amount in the account, P is that principal, that's the starting amount, and then we've got our interest rate. This is our yearly interest rate for R. N is the important number. It's number of compounding periods. If we go back to Alpha Bank, N was 1. We got interest 1 time a year. If we go to Beta Bank, N equals 4. We got interest 4 times a year, 4 different times. And if we go to Gamma Bank, N was 12 because we got interest 12 times a year. So let's do Alpha Bank. Let's do our amount equals. What's our principal on this, guys? What was our principal? $3,000. And I'll use this formula if you'd like. It's the 1 plus the interest rate for Alpha Bank was 6%. We always put the yearly interest rate up top, but then you divide it by how many times you're earning interest, right? So how many times did we earn interest for Alpha Bank? 1. So that's kind of dumb. It's like, isn't that still just 0.06 in that case? And then you do it to the number of times you receive interest, the times time. So we're doing 18 years. Isn't this still just kind of the 18th power in that case? So we can quickly and easily punch this guy in. This is what we did last class period. Normal exponential growth that you only have it happen 1 time a year. It's the 1.06 to the 18th power. And you probably never even know that this money was sitting there because you got it when you were a little bitty baby, you know, and you don't remember that stuff. But that $3,000 turned into $8,563.02. 8,500. Sorry, my elbow hit that. 63. Let's write it down better. $8,563.02. Not bad. What'd you do to earn that money? Nothing, right? You know, you just let it sit there. $3,000 turned into $8,500, just like that. Well, not just like that. 18 years. What about if we do Beta Bank? Do you think it should be more or less since we're getting interest 4 times a year? What do you think? It should be more. Let's find out how much more. Now we really have to use this formula. So it's still the principal times 1 plus the rate of 0.06, but this time it gets divided by 4, and we'll raise it to, check it out, the 4 times 18 power. I like to calculate this first. Let's do the 4 times 18 real fast to figure out what that number is. And would you believe that we will actually earn interest 72 times in that period? Because you get it 4 times a year for 18 years. That's 72 different periods of interest in that case. So punching this in can be complicated. I would like to show you how to punch this in. This is not a left to righter. To try to punch this in from left to right, we usually make some errors and put things in the wrong place. Let's do order of operations. Inside the group, let's take the 0.06 and divide it by 4, because that's pretty much what we did before anyway. Hit equals. Then guess what we do to that? We got to do what to it? Add 1. So plus 1. And now here's the question of the day. So I got that 1.015. Should I take it times 3,000 or should I raise it to the 72nd power? What do I have to do first? The multiplication or the exponent? Order of operations. We got to do the exponent. So we're going to raise this to the 72nd power and get this wacky number. Don't round anything off. And this is what we take times 3,000. And here's how much we would get. 8763.47. So we can write that down. $8,763.47. So roughly an extra $200 just because nothing changed except for how many times we earned interest. We got it 4 times a year instead of 1. So the interest on top of interest snuck an extra $200 out of that. Let's try Gamma Bank. I'll set it up and you can punch it in. 3,000 times 1 plus the rate over number of times compounded. How many times was it compounded on Gamma Bank? 12 times a year. To the 12 times 18, because it's number of times compounded times time in years. Right? So I personally scratch that out and figure out what that exponent is real quick. 12 times 18. You're going to get interest 216 different times over those 18 years. Right? So we'll punch that in. Do the 0.06 divided by 12. Add 1 to it. Raise it to the 216th power. And take times the $3,000. Boom. 88, 10, 30. So obviously, it's still not the greatest amount of money, you know, like we made an extra roughly 250, 300 bucks in that scenario. But if you have options, excuse me, if you have options out there, and it's like, well, we could give you quarterly interest or we could give you monthly interest, take the one that gives you more interest in that case. The more times they compound it, you're going to get more money out of the deal. So let's go to some basic problems, and then we'll get to the fun problems. But before we do that, let's fill out this chart of other magical words of how many periods it is. Like we had quarterly and we had monthly, but there's some that confuse people. Let's do the easy ones. How about annually? How many times a year? Once. Semi kind of means like twice, you know. So semi-annually means twice a year in that case. So you would get it every 6 months, basically. You'd get it at 6 months, and so twice a year, semi-annually. Quarterly, we do 4. Monthly, we do 12. Let's go back to elementary school. Weekly, how many weeks in a year? 50 what? Okay, it's 52, guys. 52 weeks in a year. Oh, education is failing us left and right, up and down. So biweekly is not like biweekly means every other is what we're going to say. So if you get paid biweekly or if you earn interest, it's every other week, right? So if there's 52 weeks in a year and you earn interest every other week, how many times would you get that? 26. Bi-monthly means every other month, right? So every other month you got interest. How many times a year? 6 times. And daily, maybe we didn't get the weeks right, but how many days are in a year? 300 and what? The truth is, it's really 365.25, because that's why every 4 years you get leap year, but we'll be cool with 365. But I'll tell you what, if you were that person getting daily interest in 2020, and you're like, hey, why didn't I get interest on February 29th? Hey, man, that's not fair, you know. There's an extra day every 4 years to make that balance. Number 2, an account pays 5.4% annual interest compounded. How often? Quarterly. If $4,000 is placed in this account, find the balance in 8 years. Let's use the formula. What is the principal? $4,000 times the quantity of 1 plus. This guy, you always take your rate. Got to make him a decimal, of course, because he was a percent, and divide it by the number of times compounded. Beans is how it's quarterly. Are you cool with putting a 4 down there? And then we'll do number of times compounded times time in years, which is 8 years. I scratch that and realize how many times we actually get interest. So that is 32 times. Let's punch that in. This is the last one I'll do for you. And then if you need help, you'll just have to come see me, all you people out there in video land. So you divide it by 4 first, add 1 to it, raise it to the 32nd power, and finally take that times $4,000. And I got the amount to be this. And what I would like us to do, because we are a smart group of people, is to use estimation skills. If you have me for a teacher, some of you have Dreyer and Deanahan, but if you have me for a teacher, I made my kids take a survey just to kind of guess some basic things. Here's what I would like us to get better at, because we're good at the math, but let's get better at thinking about it. First of all, time. How long was it there? 8 years. Do you think that's a long time or not a long time? Now, not for you to live, but to let money grow. Long time or not a long time? It's not really that long of a time. 8 years, even though to us, you know, like if you're going to school, it's like, oh my God, I got 8 years of school left. That's a long time. It's not long to sit money to grow. Then how was our interest? This is where I would like to help you. Usually, anything above 5% is pretty good. Right? You know, like 5% is a decent number. If it's more than 8%, you are outstanding. That is excellent, right? You know, more than 8% is excellent. Less than 5% is, you know, it's like, not that big of a deal. So would you believe this is an average scenario for not much time? Are we okay with that? We started with $4,000. We didn't make that much money out of it, $2,100. It's not the biggest deal in the world. It's nice, but it's not like we're retiring off of this in this case, right? So it's not that big of a deal. You shouldn't expect to go from $4,000 to $1 million in an 8-year period with this amount of interest. Sound cool? So let's preview this guy. How much money are we putting in? $2,500, which I know to you is kind of a lot of money. It ain't much money. If you're investing money, $2,500 is chump change, right? How long is it going to be in there? That's a decent amount. 15 years is decent, right? It's a decent amount of time. What is our interest rate? Poor, average, or excellent? I would call it kind of poor. It's not the worst thing in the world, but it's not that great. We shouldn't expect to get too much more than $2,500 when we're all said and done. I'm previewing maybe about $3,500 to $3,800 by the time we're all done, only because it's in there for a long time. How often are we getting interest? Monthly. Set it up and punch it in. Please pause the video to get this done and come back and check with me. So here's our setup. Remember, this is the trickiest part right here. Don't forget about him. And, you know, we got an extra $2,100 out of the deal. What was the big deal? Because it was there for a while, right? It was there for a while. Let's talk finally about the last one of these lamos. How much money are we putting in? Basically nothing. I'll bet a lot of you actually have $100 yourself. You know, maybe not on you, but you have that much money. It's not much money at all, you know. How much interest are we getting? Poor, excellent, or normal? Extremely poor, right? That is low, low, low stuff. How long are we leaving it in there for? 20 years. That's a good amount of time, right? So what I would like you to do is just predict how much you think that'll be worth. So let's see how much it's worth. We've done our predicting. Let's punch in. We got $100 times 1 plus the rate, which is yucky. And it's doing it how often? Bi-monthly. What does that mean again? 6 times a year for 20 years. So we'll get 120 sets of interest. But let's see if this is decent or not decent. Plus 1 to the 120th power times 100. Yay! How much? $127. And don't forget, 9 cents. Zippity-doo-dah. The reason that I made this problem up this way, it really isn't made up at all, because this is what a savings account does. A savings account, which some of you might have, a savings account offers you basically no interest at all. Very, very low rate. Why is it low? Because it's safe. It's one of the safest things around. You can put your money in there, and you do not feel that you're going to lose that money. The higher interest that you earn comes on riskier investments, right? Like obviously, there's got to be some sort of risk. There's a chance you could lose money in some investments. You've heard of the stock market before, right? You know, it's like there's definitely a chance to lose money. So the lower the interest rate, the safer that investment is. Take a personal finance class. They'll explain it in more detail to you, right? This is just an algebra class, so lots of cool things to talk about, especially on the back page.
All right, now that we've done a little bit of compound interest, check this out. We got like the best case scenario here. Suppose a bank is to offer you 100% interest on your money. Well, obviously that's not going to happen, but mathematicians are weird and they like to kind of play with numbers. So let's pretend that you're going to get 100% interest on your money. So you can see here, boom, they made that 100%. Remember, 100% changed to a decimal. You move that 2 places as the number 1. So let's see what happens when we're just going to put $1 in for our principal. So there's the $1 going in for the principal. And let's see what happens, how often we start compounding stuff. So, bro, we're getting the best interest rate in the world, 100%. So if I get interest 1 time a year, that's going to look like this on my dollar. I'm going to have all of that going in. I just put 1 in for n. I get interest once a year. Well, 1 over 1 is 1, and if you add that to this guy, don't you get 2? to the first. Cool, I don't even need a calculator. I'll have $2 left. And I hope that makes sense, that if you get 100% interest on your money and you put $1 in the bank, well, by the time that year's over with, you got $2 because you just made 100% of your money back. You had $1, you made $1, that's a total of $2. But look what happens if you get interest twice a year, like semi-annually. So here's the formula. We're putting 2 in for n, and that'll be 1.5. See, I don't need a calculator for that either. My bad, that's supposed to be a 2 to the second power. Well, we'll punch that in. 1.5 to the second. And that actually is $2.25 is what you have. So if you started with $1 in the bank and you got 100% interest, by the end of the year, after you got interest twice a year, you'd have $2.25. And then if we get that interest 4 times a year, well, we're going to even make more money, right? So putting 4 in for n, that would be 1.25, because I know 1/4 is 0.25, to the 4th. Well, let's see what that is. 1.25 to the 4th, baby. Ooh, that's a nasty guy. And here's what I want to do. I want to show you something. So we're going to write all of those decimals down. And honestly, I don't care if you write those decimals down since you're watching this video. I've got this whole process all punched out. So if I put 12 in for n, I'm going to get this. That would be like 1 plus 1 over 12 to the 12th. It would be this nasty decimal. That's if I got interest every month, Then I could get it every week if I wanted to, and I would turn out to be this. If they gave me interest every single day, I'd get it 365 times a year. And then if I got it every hour, like wouldn't that be cool to get interest every hour? And if I got interest every minute of the day, look what happens. The amount of money that we get, it starts to reach this weird limit. It's like even just the last 3 examples, after you get over daily, it's like, dude, if we was to just round this off, you basically get $2.72, It's like, so what happened was the mathematicians noticed something, and if you get into calculus, you'll see that there's something called a limit. Now, this little function, as n gets larger and larger and larger, there's a limit. You'll notice that n got larger. It started at 1, then 2, then 4, then 12, then 52, etc. It kept getting bigger and bigger and bigger and bigger. Well, there's a limit to what that number can reach, and that is about 2.718288128, blah, 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 which the mathematicians call this number e. E is an irrational number. And I know that seems weird to you, but I can tell you another guy that seemed weird to you at first was pi. The first time you heard about pi, that 3.14159, blah, 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 that was really weird, but you got used to it because you kept dealing with it. Well, e is a new weirdo. He is what's called the natural number. E shows up in nature often. Like, imagine this. If I went outside and ate a banana and threw the banana peel on the ground, that banana peel is going to decay. And you know how fast it decays? Naturally, right? It does it continuously. It's decaying now and now and now and now and now and now. And the rate that that happens at is about E, the natural number. So we've got a new formula also for today. It's called PERT is a fancy name for it, and we use it when we get continuous interest, things that happen continuously. Anytime they mention continuous interest, we're going to use this formula as opposed to the one we've been using all day. So let's suppose $8,000 is invested into an account offering 6% interest that compounds, boom, continuously. This is the word that tells us we're going to need PERT. How much is the investment worth in 10 years? So I'm going to sub it on into PERT. My principal is $8,000. That is our starting amount. There's an E next to it. Remember, E is not a variable. He's a number. We got to get used to that. He's our new number, E. It's raised to the rate, 6%. Remember, we got to change him to a decimal. And then times time in years. So that's what it looks like. I am going to now punch this in my calculator. Sorry, I hit the wrong button. Punch it in my calculator. And I'm going to get 8,000. And we got to find the E button. So I shouldn't have shrunk that down. That's why I had it all big. The E button is right here. I know that's tough to see on the video, but if you go to the number 4 on your graphing calculator, the button to the left of it is called ln for natural log. We'll learn about that next unit. Right above it as a second function, there is an E to the. So there's our E, and he automatically puts us an exponent. I need to put 0.06 times, what was it, 10? up there in my exponent. And there she is. There is our amount. Since it is money, we will round it to 2 decimal places, so this will be 95 cents in that case. So bada boom, but I forgot this is a banking situation, so the bank will always round it up. We're going to always, always, always round that guy up, so that'll be 96 cents. And don't forget your dollars. And of course, we need a comma in our large numbers. So $14,576.96. We will always round that guy up. So let's try that again. Suppose that this much money is invested into a college fund offering 7% interest that compounds, boom, continuously. That's the magic word that tells us we have to use this formula. How much is the investment worth in 18 years when the child is ready to enroll in college? Well, let's sub it in. 20,500 is our principal. E is just the number that's in the formula. That's the rate that things are growing by. And 7% like continuous interest, so we change that to the decimal, and 18 years. So let's punch that in. 20,500 times E, so second, and then that button right there, to the 0.07 times 18. Boom. And we'll call that 15 cents. So $72,271.14, 15 cents. I guess I don't care how I'm rounded since I got these all kind of figured out already. So 14 cents will be fine. If you rounded it up to 15 cents, that's fine also. Apparently, I just made a mistake on this one. That one should have been 95 cents. So whatever. Being off a penny ain't going to hurt my feelings. How about Yolanda? She got a big bonus of 15 grand at work. That's nice. She's still 12 years away from retiring, so she decided to invest all of this bonus money. How much would her money be worth if she put it into an account that gives 6.5% interest compounded, boom, monthly? So we will have to use the old formula because they didn't say continuously. We got to do this guy, amount equals the principal times the quantity of 1 plus our rate over the number of times compounded to the n times t formula, the one that we were using earlier. So let's sub that stuff in. I got 15 grand as my principal. Remember the percent changed to a decimal. You got to move him 2 places to the left. 12 times a year is what monthly means. And it's going to be 12 years, so I got 12 times 12, and I went ahead and scratched that and called that a 144. So let's punch that in. I'm going to get this nice and small so I can see what I'm punching. To punch it in, we will start inside the parentheses first, so I'll do the 0.065 divided by 12, and hit equals. Add 1 to it, and hit equals. Raise it to the 144th. And hit equals, and take that times our 15 grand. Bam, 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 boom. And that is what we got. So it looks like 28 cents in that case. So cool. Don't forget your commas and your dollar signs. But we couldn't use PERT because they didn't say continuously. They said monthly, or if they say daily or anything. The only time you use PERT is when it happens continuous. How much more money, meow, 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 would Yolanda have if she found a bank offering what kind of interest? Continuous. That's a PERT situation. So let's sub her on into PERT. The principal is this, times e to the rate times time power. And we go ahead, and I'll let you punch that guy in. 15,000 times e, maybe, to the 0.065 times 12. Boom. Got this guy right here. So that's how much that turns out to be. But they didn't ask how much would she have. They say how much more money would she get. More money. So what you got to do is you got to subtract those two dudes. And when you subtract them, wow, what a difference. Isn't that something? That if you got interest once a month, so if I snap my fingers now and waited a month to snap my fingers again, that's how long it took for a month to pass. But if you get continuous interest, meaning now and now and now and now and now and now, like it only adds up to an extra $68.80 more that she ended up getting. And that's over 12 years. So it's amazing how you'd think continuous interest would be that big of a deal, but it's actually not. You know, once you get monthly, It's almost about the same amount. So what a day. Got some interest stuff. Let us know if you have any questions, and have a good one.